Okay, so here he wants you to work out the loan, some loan value, and the first function we're going to use is PMT, payment. That means payment. So you can see the syntax here. You've got the rate. N per means n periods. So as you know in maths, you've got to designate an unknown number. They usually put n. So that means n number of periods. And then present value means the present value of something, and the future value means the future value of a figure. And the future value is what is the time value of money concept. So if we split these out, N per PV FV. Yep. So if this would be based on a year basis and month basis. Yeah, so he's given you in this first, so remember in this he said show each of your 4 final decisions in 4 different worksheets. Name the worksheets: F1 decision, F2 decision, F3 decision, F4 decision. So you just create different worksheets. F1 decision, yep, create that. F2 decision. Okay. So rate. So he says Lloyds Bank offer a loan of 100 grand at an interest rate of 7% per annum. Then monthly, the repayment period is 20 years, but it's monthly. So he wants you to work out monthly compounding. So when that ever happens is obviously 20 years. However months there are in 20 years, there's 12 every year. So it's 20 times 12. The rate is 7%, but it's 0.07, yeah? Because that's percentage. Don't get confused. Never put 7 in there. It has to be 0.07 equals that divided by 12. It's a monthly interest rate, it's not a yearly interest rate. And then your present value, which is the value as it is today, is 100 grand, and that will be the same. Yeah, it's always going to be 100 grand. So there's your syntax. Let's work it out. Per month equals PMT rate, it's that, comma, that, and then your present value. And this will be our monthly repayments, yeah? So 775, and the reason it's negative is because it's showing it's going out of your pocket. Yeah. So that's F1. Okay. So so it's saying if Babs can only afford 1/4 of the monthly repayments, calculate the amount of loan that Lloyds Bank can offer Babs. So values 7 minus 7 point, so just take that out, calculate the amount of loan. Okay, so then you would just do the present value. The rate would be what it was before, so just make sure you go back on the rate before, which is that monthly, the number of periods, and then the payment is this. Yeah. So that we know then is right, yeah? We know that's right because it's giving us exactly the same figure. Because the present value, because the way that works is your payments based on that interest rate, that present value, and that number of periods, you should be paying back 100 grand over the lifetime of the loan. That's how much you should be. You'll be paying more than that because you'll be paying interest and stuff like that. But that's what that present value is saying. What would the value of this today, if you were to pay £775 for 240 times, based on that rate, 7%, what would that be of value today? So what money would you get for that today if you were to give £775 to a person over 20 years? What would be the equivalent of that in money today? Which would be 100 grand? Because obviously they're saying today 100 grand is going to be worth a lot less in 20 years. So to compensate for someone giving you £100,000 today, you have to give them £775 over 20 years to compensate for that. And usually what's built into that interest rate is things like inflation, credit risk, the time value of money, the risk-free rate, which is the rate that you would invest in bonds, in government bonds, and all that together gives the bank or whoever's lending you the money the profit that they want. So let's take that and times that by 25% because she can only afford a quarter of it, which is £193. Okay, and then just drag that one across, right? So it'd be 25 grand. I mean, makes sense, right? If Babs decides that taking the loan, she would rather invest the repayment amounts in 1 and 2 different ranks under. Okay, that's just the future value. So that's what I was saying. What money like this would be, how much you'll be paying back in the future. Okay, so copy and paste those amounts. You're going to paste special as values. Yeah, just copy and paste them as values across. And what you would do is just do that. It's the future value this time. Take the rate, which would be down here. Can move that out of the way. Yeah. Put F4 here. N per number of periods. It's here. Yeah. And then I'll put the input here. And then put the payment amounts up here. Voila. What's happened here? Where's the rate? Okay, the rate's gone funny, that's why. Make sure you get the rate right. Got that the wrong way around. So the rate F4 and N per. No, yeah. There we go. That makes sense. Make sure you've got F4 on here because as you can see I didn't. There we go. Okay. And that will be the amount if Babs was to invest that every month, an interest rate return of per annum of 7%, she would be, in 20 years' time, she would have £403,000 worth of savings or investment amount. And if she was to invest £200 a month, she would have, at that rate of 7% an annum, she would have 100 grand. Okay. Okay, yeah, so that's it then. Just double check that I've got the same answers. Okay. Okay, so you just need to make sure that one of them's, that should be in, that should be the F3 decision. Yeah. And this should be the F4. So just cut that. But yeah, that's that then. Nice and easy.